All right, here's our free response question from our practice test. A recent study revealed that a new brand of MP3 player may need to be repaired up to 3 times during its ownership. Let R represent the number of repairs necessary over the lifetime of a randomly selected MP3 player of this brand. The probability distribution of the number of repairs necessary is given below. Okay, so the values are 0, 1, 2, 3, probabilities 40, 30, 20, and 10%. Part A, compute and interpret the mean and the standard deviation of R. Okay. All right, so the mean we'll actually calculate by hand. College Board would expect you to do this. So it's the sum of each value times its corresponding probability. All right, so 0 times 0.4 plus 1 times 0.3 plus 2 times 0.2 plus 3 times 0.1. All right, and that gives us 1. Okay. All right, let's do all the calculations and then we'll write the interpretations at the end. All right, so the standard deviation of x, here's the formula, right? You take each value, you subtract its mean, you square it, you multiply it by the corresponding probability, you add it all up, and then you take a square root. Okay. Now, this is an FRQ question. Just to be on the safe side, I'm going to try to show a bit of work, but secretly I'm going to use my calculator to get the answer. Okay. So here's the work I'm going to show. Okay. I'm going to plug in the first value in probability into this expression, right? So this would be 0 minus the mean 1 squared times the probability 0.4. Let's say times. Okay. And then I move on to the next value. So then it would be 1 minus 1 squared times 0.3. And then the next term would be 2 minus the mean 1 squared times 0.2. And then the last term is going to be 3 minus the mean 1 squared times 0.1. And then don't forget we have to take the square root of the whole thing. Okay. Actually, now that I'm looking at it, it's not even that hard to calculate because this basically would be the square root of negative 1 squared times 0.4 plus 0 squared times 0.3 plus 1 squared times 0.2 plus 2 squared times 0.1. Okay, and then I can go back in and simplify. Negative 1 squared is just 1. 0 squared is just 0. 1 squared is just 1, and 2 squared is just 4. All right. And I don't mind, like, this isn't too bad for me. This shouldn't be too bad for you to just, type that in your calculator. Okay. All right. So when we do that, when we type that expression into the calculator, we just get 1 again. All right. So surprisingly, the mean of this random variable is 1, and the standard deviation is 1. Now, if you didn't want to do all that math for the standard deviation, then what you should be doing is typing the values into list 1 on your TI-84, typing the probabilities into list 2 on your TI-84, and then using the calculator's command 1varstats. All right. Now we've got all the values. We need to interpret it still. I don't have any space, so I'm going to just shrink that down. Not too small. All right, and then now we can write the interpretation. All right, so first the mean. All right, so we could say If many MP3 players of this brand are sampled, just start with that. If many MP3 players of this brand are sampled, then the average number of repairs will be about 1, right? So your typical MP3 player is going to need 1 repair in its lifetime on average. All right, now even that is a little bit too big. I didn't leave myself that much space for the standard deviation. All right, so now we'll interpret the standard deviation. So with this interpretation, you want to make sure that you include the words typically varies from the mean somewhere within your sentence. All right, so I'm going to start with the context. The number of repairs for MP3 players of this brand, okay, I guess I should add that in, for MP3 players of this brand, typically varies by 1 from the mean of 1. All right, but we have typically varies from the mean. All right, let's move on to part B. Suppose we also randomly select a phone that may require repairs over its lifetime. So first was MP3 players, now we're talking about phones. The mean and standard deviation of the number of repairs for this brand of phone are 2 and 1.2 respectively. Assuming that the phone and MP3 player break down independent of each other, compute and interpret the mean and standard deviation for the total number of repairs necessary for the 2 devices. All right, so let's define a new variable. So we already have R for the, I guess R for repairs, but that's for the MP3 player. So let's choose S. I guess it's just the next letter in the alphabet. So S is the number of repairs for a randomly selected phone. Okay, and we know the mean of S is 2, and the standard deviation of S is 1.2. Okay. Now we also had R, which is the number of repairs for a randomly selected MP3 player. And the mean of R is 1, and the standard deviation of R is also 1. Okay, but the question is asking about the total, right? So the total number of repairs is going to be S plus R. S being the repairs needed for the phone, R being the repairs needed for the MP3 player. Okay. Now, when you add 2 variables, as you would expect, the mean is just the sum of the old means. Right? So it's the mean of S plus the mean of R, or 2 plus 1, which gives us 3. The standard deviation, one might think that it's just the standard deviations of the old variables added together. Okay? But one cannot simply add the standard deviations. You can add their variances and then square root that result. Okay. So this is going to be 1.2 squared plus 1 squared and then square root. And that is 1.56. All right. So we computed it. It also said to interpret it. Goodness. Where's the space for all this work? Okay. Well, I'm going to have have to make some space. All right, so first, let's interpret the mean. All right, so we could say, if many phones and MP3 players are sampled together, right? Or if many combinations of phones and MP3 players are sampled together, I guess I'll go with that. If many MP3 phone pairs are sampled on the average, not on the average, the average number of total repairs will be about 3. And then for the SD, we could say the number of total repairs typically varies by about 1.56 from the mean of 3. Yeah. So again, using that phrase, typically varies from the mean. And then in the first interpretation, we're making sure we include the word many and average. All right, last part. Each MP3 repair costs $15 and each phone repair costs $25. Compute the mean and standard deviation of the total amount you can expect to pay in repairs over the life of these devices. Dang. All right, I'm going to define some new variables here. So never used X yet, so let's use X. X is the repair cost of an MP3 player, and Y will be the repair cost of a phone. Okay. Now, X is just the number of repairs for the MP3 player times 15. Right, so we're just multiplying by a constant. Y, the repair cost of phones, well, it's just the number of repairs for the phone, which we used S. I'm kind of regretting my choice of variables here, times 25. So that's just multiplying by a constant as well. Okay. All right, so the mean of X will just be the mean of R times 15. Right, remember, multiplying stretches a distribution. So it stretches the mean. It's going to stretch the standard deviation as well. Okay, so let's write this down. The mean of X is going to be 15 times the mean of R. That's 15 times 1, so $15. Okay, the standard deviation of X is just 15 times the standard deviation of R. That's 15 times 1, so $15. Okay, all right. The mean of Y is 25 times the mean of S, which is 25 times 2, which is $50, right? So remember, we expect about 2 repairs on average for a phone, $25 a pop, so that's, you expect to pay $50 over the lifetime of that phone. The standard deviation of Y, that's going to be 25 times the standard deviation of S, and that's going to be 25 times, standard deviation of S was 1.2. Okay, 25 times 1.2 is 30. All right. Now, what was the question? The question was compute the mean and standard deviation for the total amount that you could expect to pay in repairs. So the total cost. Okay. Now I'd use T, because T for total, but I already used that in a previous problem. So I've got to define a new variable here. I guess I could just use C for cost. Okay. So the total cost is just X plus Y, right? It's X, the cost of the MP3 player, plus Y, the cost you pay to repair the phone. Okay. So we're just adding two variables together again. So the mean is just going to be the sum of the individual means. So that's 15 plus 50. So 75. Okay. The standard deviation is going to be not this, right? You're not adding the standard deviations. You're going to add their variances and then square root. So the variance of x, that'll be 15 squared. Variance of y, that'll be 30 squared. And then we'll have to take a square root. Okay, 15 squared plus 30 squared. Square root of 33, 54. All right, so that was definitely a ton of work. We defined a lot of variables in this problem. Let's just kind of recap if you're still with me here. Okay, so the first variable was already defined. It was R. Okay, probably not the best choice, right? Maybe they should have used M because they're talking about an MP3 player, but whatever, they used R. Okay, all right. And then the next variable was S, right? And that was my bad for choosing S. That really didn't match the context. Probably should have used P, right? P for phone. But anyways, S was the number of repairs for a random phone. R was the number of repairs for a random MP3 player. T was the total number of repairs if somebody owned both devices. All right, so that's three variables right there. And then we defined three more variables that were not about the number of repairs, but were now about the cost associated with those repairs. Right? So X was the cost of repairing MP3 players, a random MP3 player. Y was the cost of repairing a random phone. And then C was the total cost of repairing both devices if you own both devices.